Good afternoon, everybody. This is a practice activity, a perfect practice activity for the identification of elements that make up a chemical formula and how to calculate the molar mass of a chemical formula. Many of the notes that we will see here we went over in class already. Feel free to use this information as supplementary. You may pause the video to go through and add them to your notes where it is appropriate. But we're going to focus in on the tasks of identifying and reading a chemical formula and calculating molar mass. So remember that chemical formulas identify the types of elements that make up a compound, and it identifies the number of atoms that element that element that are involved. So for example, when we look at water, it has a chemical formula of H2O, meaning that it is made up of two elements, hydrogen and oxygen. And then the subscript behind the H means that the compound has two atoms of hydrogen, and with no printed subscript behind the capital O, that means that the compound only has one atom of oxygen in a molecule. So we are going to practice right now for identifying the elements involved in the compound and their quantities. So please make sure that you want to pause the video when you get to the question, work through it on your own. In this case, you want to jot down the chart, fill in the missing information, and then play to double check your work. So for this one here, our question is, how many atoms of each element are involved in the compound? And I apologize for getting that so short, so let's move this over here. And here we go. So remember to pause. You want to double check the formula. So for the first substance here, for sodium chloride, identify which elements are involved in the compound and tell me how many. And when we look at this, we have one sodium atom and one chlorine atom. Remember, when we take a look here and we take a look at the element Na, there's no subscript behind Na. So there is only one atom of sodium, and the same applies for chlorine, the Cl here, only one atom of chlorine. All right, go ahead and try carbon dioxide. You should see one carbon atom and two oxygen atoms. And for the last one there, sodium carbonate. Remember, pause the video, work the question, double check by playing. So you're pausing now, and your answer, 2 sodium atoms, 1 carbon atom, and 3 oxygen atoms. So being able to identify how many atoms are involved in the compound is necessary for the next step. So the next step is we want to calculate the molar mass of the compound. The molar mass of the compound is really simple. You just add up the masses of the individual elements that are involved in the compound. Now, when we have multiples of an element, we want to add in multiples of that mass. So, for example, when we take a look here with the molar mass of water, you will notice that there are two atoms of hydrogen here. So when we go to calculate the molar mass, we're going to multiply the mass of hydrogen by 2 when we add these together. Okay, there's no subscript behind the oxygen, meaning that there is only one atom of oxygen. So we're just going to take the 16 once, and then when we have the molar mass, the way we read this is 18.016 grams per mole. Remember that the raised subscript -1 means we're looking at per mole. So let's do some practice problems. Okay, for each compound, I want you to calculate the molar mass, and to help save you some time, when you pause the video, you will see that the masses of the individual elements are up here. These are taken from the periodic table that you were given at the beginning of the school year. And again, remember, you need to pause this video because I'm going to go through and answer these really quickly. So if you don't pause it, you'll miss out. So chemical formula, and then I'm going to show the math, and then the overall final answer of molar mass. So go ahead and pause for each one and go through and do your calculations. Now, when we have sodium chloride here, we only have one atom of sodium, so I'm going to take that 22.98997, multiply it by 1, and then I'm going to add it to the mass of one atom of chlorine. So we end up with 58.44247. Now, I will tell you, on testing quizzes, you may have a rounded number here that you can use for these individual numbers. That's fine. I just, the one that I copy here, that was from the one that I gave you at the beginning of the year. All right, so for CO2, we have one atom of carbon, or 1 mole of carbon. We have 2 moles of oxygen, so we need to multiply that by 2, and when you add it together, you should get 43.9987. And then the last one, we have 3 different substances. So to help you identify some stuff here, here's the 2 times the molar mass of sodium. Here's the 1 carbon, and then finally the 3 oxygens, 3 times the mass of oxygen, added together to 105.97224. Now, if you have any questions about this, jot them down off to the side, bring them into class. These would be excellent questions to cover in tutoring or to cover before or after school. Thank you.